Students, welcome back. Now, this one I've been looking forward to. This is one of my favorite topics of all. Okay, and so it's about the right angle triangle, and it's defining three very important functions called sine, cosine, and tangent. Okay, shortened up on the calculator to SIN, COS, sine, cos, and tan on our calculator. Here, sine is the same as sine, pronounced the same. Cos, pronounced like here, or cosine, and tan are also pronounced tangent. So these are abbreviations for these words here. Okay, the important thing is you don't have your book in the exam. Let me just delete that one, we're finished it. We do have our log tables though, and I've just zoomed in here on any bit we want, okay, on the right angle triangle section. Just to show you, this is a right angle triangle. Down the bottom, yes, we saw Pythagoras theorem, we did that in the last video. Now we're doing sine, cos, and tan. Okay, so what's that thing there? Oh, that's our book itself. I should be using that too so we can see what you're looking at and so on. Okay, so we have everything we need in the log table, so let's just jump straight in. Okay, sure enough, we'll do the example. But I think I have the example dialed in here on my camera, so let's do it here. Okay, so we come back to that. Now the tan of B. So I always want to use the slightly elongated triangle. So let me model this up here with a B as our reference angle. Now, of course, the reference angle, this can be turned any way at all. But if you're given a choice, let's put the B the same place everywhere. So what this tells me is this should be 5. This should be 2. And when we can go ahead and use Pythagoras to get this. Okay. Now, in terms of using Pythagoras, I just want to show you something else. Remember what I said, that we can also write this as root 5 and this as root 4, which then means this here is root 9, which is 3. Are we all okay there? That doesn't look quite fine. Yeah, it is. Okay. So, or if you're applying the formula, you're basically saying root 5 to be squared. They cancel out, but we'll do this in the calculator just to convince you, and 2 squared. Okay, so let's bring up our calculator. Bring it down a bit there, make it a bit bigger, and we'll just jump into it. And what I'm saying here is I have a root of 5, and I'm escaping out from the root, and I'm squaring it, and I'm plussing a 2 squared to that. Okay, and sure enough it's 3. That's that one done. Oh no, hold on. Now I gotta go on using it with 3, root 5, and 2 to ask what's the sine. The sine of B is root, so let's just write that here where I have space. The sine of B is opposite over hypotenuse, root 5 over 3, and the cos of B is these two. Cos of B is adjacent over hypotenuse equals 2 over 3. Okay, and I suppose on a reflection you might need this because I didn't do that in class. Now find the sine, cos, and tan of the angle marked with a capital letter in each of the following triangles. So what we're going to do here is, we have to do all 3. So I'm going to go sine A, cos A, tan A. So let's get into it. Do we know how to get the sine? The sine is the opposite. So think of it as visual learning. You're going across. It's 3 goes on top, and then you're going over to the hypotenuse over 5. Now for cos, you're not going to cross, you're just taking a look at your local number that's between you and the right angle. You're not looking out along the hypotenuse, you're looking at the side that takes you to the right angle. which So cos, go to, look, have a trip to the right angle and see what side you see. 4 over 5. And tan of A is 3 opposite compared with adjacent, so 3 over 4. And sine of B equals 5 over 13. Okay, up. So you just have to get used to doing these. Cos of B equals 12 over 13, and the tan of B equals 5 over 12. And the sine of C equals, now you think you're going on a journey across, it's all relative to where you are, so root 3 over 2. The cos of C, so C down to the right angle, you're picking up your 1 over 2, and the tan of C is root 3 over 1, which is just root 3, you don't have to put it over 1. 60 degrees, by the way. Okay, that's that one done. Let's have a look at the next one. Non-continuous. Oh, my zoom is too high. Hold on. Alright. In the given state, which of the ratios sine, cos, tan connects 3 and 4 and the angle A? 3 and 4 is tan. Look where they meet. They meet at the right angle. It's like there's a T here at the right angle. Tan connects 4 and 5. Look at where 4 and 5 meet. They meet at the reference angle. It's cos. 3 and 5. 3 and 5, they meet at the complementary angle, the empty angle. It's sine. Darn it, my camera was off. Sorry about that. Okay, we're going in. In the given triangle, I think you were able to read it. Connects 3 and 4. So look at it again. Where does 3 meet 4? It meets at the right angle. That's tan. Connects 4 and 5. 4 and 5. It meets at the actual reference angle. That's cos. Okay, and connects 3 to 5. Meets at the complementary angle. That's sine. Write down what should be inserted into each of the following. So 13 is hypotenuse, so we're looking for opposite 5, so the sine of A. Actually, let me look here and talk to you here. Okay, write down what should be inserted into each of the following. So something connects cos. So if it's cos, A will have a 12 on top, B will have a 5 on top. It's the cos of B. This is a nice exercise, I have to say. Tan should look across, whatever angle is looking across at 12B. Okay, what puts 12 over what in terms of A? There you go. Look at that. Circle that. You go. That's cos, because if you get that triple, if you get that included angle is A, it's cos. Okay, now 5, 12, and A. That's tan. Okay, and we're over here now, looking at the B one here, and we're going, hold on now, there's B. What trig function will put 5 over 13 for B? Well, there you go, it's cos, because they're all circled together there. That's cos as well. Okay, question 4. Find the length of the side marked X in the given right angle triangle. Well, that's Pythagoras. Look, I happen to know it's 8, and I'm going to show you a little bit of extra stuff here. Okay, I know by inspection it's 8, but I would assume you didn't know that. So we would go with my calculator and clear it. We'd go with the square root of the hypotenuse squared. And the minute you hear hypotenuse squared going into Pythagoras, you know it's a minus. 15 squared. And like I said, I know it's 8, and I'm going to tell you a little bit of a story now. Okay, so x equals 8. So the story is, earlier today we were looking at taking odd numbers and turning it into two numbers that were 1 apart. Well, another thing we can do is go through a series of Pythagorean triplets where we start with a multiple of 4. Now this is a little bit involved, but you're on YouTube, so you got a video and you can pause and you can delay, and you only look at this if you really love maths. Half of 8 is 4, square it is 16. So divide by 2, 4, square it is 16, and jump down 1 and jump up 1, and now they're 2 apart. Last time they were 1 apart. Just recall another one of these is when you go with an odd number and square it and partition it to an even and an odd. I'll do another one. Take an odd number and square it, 25, and partition it to an even and a larger odd. Take an odd number 7, square it to 49, and partition it to 24, 25. It goes on and on and on. It's great fun, lads. 9 squares to 81, you've got 40 and 41, making a Pythagorean triplet. 11 squared to 121, so you have 60 and 61. It goes on and on and on, but you're probably happy enough stopping there. Okay, and 16, what am I doing here? Yeah, half of that. Yeah, so here you go again with a multiple, any multiple of 4, so 12. 6, half at 6, squares to 36, 35 and 37. And I guarantee you, let's say to double check are they equal, we'll put 37 squared over 12 squared plus 35 squared. What's the betting? What's the betting? Are we going to get 1? You betcha. Okay, anyway, let's do this. So we know now there's an 8 here, and they want to know the sine of A. So the sine of A is 8 over 17. You can see the included angle there is the complementary angle. 8 over 17. The cos of A is just go pick up the leg length from A is 15 over 17, and the tan of A is 8 over 15. Now you need a bit of practice with these, so this is why these videos are very important. Okay, find the value of A. Now we'll write this as root of 9. 9, so this is Pythagoras on steroids. This is the coolest way of doing it. Write it as a square. Now if you want to do it the other way, you'll go square root, and if you square, well, I'll do it in the calculator. So you'll go square root, and you say, look, I don't have to do it. When I square my square root of 13, I get 13. Okay, and I'm doing a subtraction for a leg, so I'm minusing, and you're minusing 3 squared. Okay, and you get the answer of 2. I'm just doing it another way. 13 take away 9 is 4 going under square root, and that turns into 2. So that's done now. At least we've 3, 2 and 13. Famous, by the way. I mean, what you're doing is you're taking your square root of 13. This isn't just any old number made up. It's the sum of 2 squares. Because that's what you're going to see out here if you want these to be integers. Okay, so you're learning so much maths now if you're listening to me. Okay, what would another sum of 2 squares be? Well, you could have 2 and 5. 25 and 4. You'll see 29 down there a lot. Okay, you'll see, we won't see 3 and 4 because they produce a whole number. That won't produce a square roots. You know, but most of them could produce square root. Let's get on with this. So we have a 2 written here now. So B's up here. Sine of B, 3 over root 13. Cos of B, 2 over root 13. Tan of B, 3 over 2. Tan is the only one that can be bigger than 1, and it is bigger than 1 for anything bigger than 45 degrees. The angle theta and 3 sides of a right triangle are shown. State whether each of the following represents sine, cos, or tan. Okay, so 4 over 5 is tan of theta. So basically, you see the 4 and the root 41. We want to see where they meet. Okay, let's come back to this one. Where does the 4 and the 5 meet? They meet at the right angle. It's tan. So this is the included angle. Speed, sine, cos, and tan on speed. Okay, so 4 on speed dial, I should say. 4 meets 5. It's tan. Look at the included angle. The included angle is the complementary angle. That's sine. The included angle is the reference angle. That's cos. Now, cos of b. So think b is here, and here it's included between these for cos. So basically we're putting a 5 here and a 13 here. Sure, the rest is history. We know a 12 goes there. Or do we? If you don't know, you can use Pythagoras to get the 12 here. This is the right angle. Draw a rough sketch and use it to write down the ratios. The sine of b is going to be equal to 12 over 13. And the tan of b is equal to 12 over 5. On to question 8. If tan of a equals, so basically, okay, and I want to tell you what you're doing here. When you're given a ratio, when you're given a sine, cos, or tan, a trigonometric ratio like this, you're to start drawing a triangle. Now you can be using your drawing kit, but you don't have to. Just draw a generic right angle triangle. Like just do it by pen and paper. So this is called mathematical modeling. Put in your A as your reference angle. Okay, and just say to yourself, look, know that tan is this over this. So 1 is upstairs and 2 is downstairs. Okay, now if we're to get sine, we need to know this. Okay, but this is simply the square root of 1 squared plus 2 squared. So this is equal to the square root of 5. And just tidying that up clean, I have 1, 2, and root 5. Now find the sine 1 over root 5. Now again, just draw any triangle. There's no particular place or thing. Just put a b in here and put a right angle here. Now remember, with cos you're dealing with these two things. You're dealing with these two sides because you should know that for cos. So these are the two numbers we're looking at. This one is 2 and this one is 5. Okay, so we're getting this one. Look, we can get it with subtracting. 5 squared minus 2 squared. 25 take away 4 root 21. We can be absolutely sure. Just take my time and do it again. I'm going to get the same answer, but I just want to be sure. Okay, square root of 5 squared minus 2 squared equals root 21. And you definitely don't want to be putting that to decimal now, lads. If you do, it's not exact, and you throw away. You've changed the situation here, and then you're not modeling it properly. Okay, and it's going to be very frustrating. So we have root 21 here, 5 here, and 2 here, and we're asked to find the tan of b. So the tan of b is root 21 over 2. Now, take the rest of the sheets off the printer, and of course, I don't know, is there any, talk to you, do you like me looking at the answers to show that they're right? Am I showing off? Of course they're going to be right, says me. Root 21 over 2 and root 5. Yeah, you know what, I like looking at them. I like being sure that I'm right. I'll make mistakes, and it's very rewarding. So from now on, we're going to bring this in and have a look. And apologies I didn't do that up to now. Okay, here we go. Question 9. If tan of c equals 1 over root 3, mark in c anywhere, put it there, always where we'd put it. 1 will be opposite, root 3 will be here. Call that root 3 if you want. So this is root 4, this is 2. Okay, and on we go. Find the values of sine of c and cos of c. For the sine of c, here's C, come across to 1, go over there to 2. Okay, compare the opposite to the hypotenuse as a ratio. Compare now cos. Compare the adjacent to the hypotenuse as a ratio. Now that's 60 degrees, I think. No, it's 30 degrees. That's 30 degrees. More about that later on. When we look at it, question 9. Okay, 1 and root 3 over 2. Use Pythagoras' theorem to find a third form, root 2. Write down the sine of A. So this is very famous. This is a special one. I just show your log tables. Okay, in your log tables, you come up, they have this table here, but actually better still, I'll be going through this in class at some stage, and I'll make a video on it. It goes like this. Well, if this one is to 1, and you apply Pythagoras, you get root 2 here. It's obviously root 1 squared plus 1 squared, it's root 2. Okay, and then there's another very famous one, which just says, look, I'm going to put a 1 out here and a 2 here. So if this is 1 and this is 2, then we can work out this one here is the square root of 2 squared minus 1 squared, or root 3. So 1, 2, and root 3. Now you could say, why make up these questions? Well, this is 1 and 1 is 45 degrees. And this one here is, you can do inverse sine, cos, or tan, and you see it's 30 degrees and 60 degrees, so they're actually quite special. Okay, I was talking away there for ages and you were looking at this, weren't you? Okay, I'm still going to keep the video going because otherwise we'll never get it done. So you have 2 going here, 1 going here, and that produces a very special set of angles that are in here. What I might do is just stop showing you this nice clean version and start having it printed out here. Look, more about that some other time. Let's drive on. We're going great with these. Didn't have to show you all that at all. Well, they're all the same. So sines are they're all 1 over root 2. Okay, question 11. Given that in a right angle triangle the sine of A is a half, so they become flippantly easy after a while. So because you're going through a process of putting A here, you're saying, I know I have a 1 opposite me, and I know this is the hypotenuse. So this is 1 is the opposite, 2 is the hypotenuse. You can apply Pythagoras' theorem to get this in case we need it, which we will if we're doing any cos and tan. So we'll apply Pythagoras' theorem. Let me slow it down. That squared minus that squared, because it's applying Pythagoras on a leg. Okay, well that's our famous friend 1, 2 is to root 3. Write down the cos. Well, where's my A gone? It's here. The cos of A is root 3 over 2. Now don't be tempted to do them the other way around because you think root 3 is bigger than 2. Root 3 is smaller than root 2. And the tan of A is equal to 1 over root 3. It's 30 degrees by the way, but that's all going to come up on the next section. In a right angle triangle, tan of C is 8 over 15. There's your 8 over 15. There's your 8, 15, 17 again. Remember, just a quick one it's a leg is 8. Half of 8. It's a multiple of 4, okay? Half the multiple of 4 is 4. Square it. This is just the joy of maths, a special situation. Square it is 16. Climb down by 1 to the predecessor, it's 15, and go plus 1 to its successor. That's what you call it. 1 up from a number is its successor is 17. and you have 8, 15 and 17. Anyway, we can just start off like this and say C is here, opposite me is 8, below me is 15. There's my right angle. Draw a rough sketch of the triangle and hence find in fraction form the value of these. So 17 goes there. Sine of C is 8 over 17. They didn't tell you. Yeah, well, yeah. You would go naturally to continue on to Pythagoras. Sine of C is 8 over 17, and cos of C equals 15. Now look, 15 over 17. Happy days, on to the next one. There is no next one. Happy days, on to the next section. As always, students, I will see you in, I'm upside down, in the next one. Okay. I don't want to do that. I want to do that. See you in the next one.